Hello, and thanks for clicking on this next Prenarculus production. Today, we're going to be talking about more with inverse trig. We're going to work with some properties of inverse trig. We're going to work with inverse trig and how they relate to making triangles like we did back when we worked off the unit circle. So we're going to do a couple of things here. All right, so let's get started. So let's start with a couple of examples here. I want you to find for me the sine of the inverse sine of root 2 over 2. Okay, so when we work these, we work in the parentheses first, and then we work outside, just like we would order of operations. So let's talk about the inverse sine of root 2 over 2. So the inverse sine of root 2 over 2, I'll come over here. Inverse sine lives in quadrants 1 and 4. I'm asking you for the angle, right? It's positive, root 2 over 2. So my answer is going to come from quadrant 1. And in quadrant 1, the inverse sine of root 2 over 2 would be pi over 4, right? So in place of inverse sine root 2 over 2, I'm just going to write pi over 4. Now, I want you to find for me the sine of pi over 4. Well, sine's the y-coordinate. I go to pi over 4. The point of pi over 4 is root 2 over 2, root 2 over 2. So that answer is root 2 over 2. And that's my answer to this whole thing, root 2 over 2. Okay? All right, let's come over here. If that felt a little bit circular, like we just kind of went around in circles, you're on the right track. So let's take a look at this example here. Now I want you to find the cosine of the arc cosine of negative 1/2. Okay, so inside the parentheses is arc cosine negative 1/2. All right, arc cosine lives in quadrants 1 and 2. One where it's positive, one where it's negative. My answer is going to come from quadrant 2 because I want negative 1/2. So negative 1/2 for cosines, the x-coordinate, that's going to be the angle 2 pi over 3. So now I want to find the cosine of 2 pi over 3. Right? The inverse cosine of negative 1/2 is 2 pi over 3. So now I want to find the cosine of 2 pi over 3. Well, cosine's the x-coordinate. So let me come over to the x-coordinate here at 2 pi over 3. It's negative 1/2. Root 3 over 2 is the point. So the cosine of 2 pi over 3, that's negative 1/2. And again, it may feel like we just went around in circles. And we did. So there's a property here that involves inverse trig. I mean, basically what we did here is I asked you for the inverse sine of root 2 over 2. So I told you the point on the unit circle. You gave me the angle that it belonged to. But then I asked you for the sine of that angle, which means go on the unit circle and find the point at pi over 4. But we just used the point to get the angle a minute ago. So yeah, of course we get the same answer, right? We end up back where we started. Okay, so this property works as such. If you're asked for the sine of the inverse sine of x of some point, the answer is x. That holds true for all 6 trig functions. The cosine of the inverse cosine of x would be x. The tangent of the inverse tangent of x would be x. Okay, you could just basically knock out the sine and the inverse sine because they're going to do the opposite things of each other, and you're going to get the same answer that you started with here. All right, and then it happened again over here. Okay, now notice that we wrote it like this. It's important. Sine of the inverse sine. The inverse sine has to be in parentheses. You have to find the angle first, then do the ratio. Because if it's the other way around, it's not necessarily the same answer. Sometimes it is, and sometimes it isn't. So let's take a look at an example here. Let's find the arctan of the tan of 5 pi over 4. So the only difference between what we just did a minute ago and what we're doing now is I'm asking you to find the tangent of 5 pi over 4 first. I'm asking you to go on the unit circle and find me the ratio off the unit circle, and then I'm going to find the angle for it. So tangent of 5, let's go to 5 pi over 4. That's here in quadrant 3. At 5 pi over 4, the point is negative root 2 over 2, negative root 2 over 2. If I divide them, y over x, it gives me 1. So the tangent of 5 pi over 4 is 1. But now, all I want you to do is find the arctangent of 1. So you're thinking, oh, well, that should be easy. That should just be the angle that I got it from. But here's the problem with arctan. Arctan doesn't live in quadrant 3. Arctan lives in quadrants 1 and 4. I can't get an answer from quadrant 3. I'm not allowed to write 5 pi over 4 as my answer for inverse tan. So I'm going to have to pick the angle from quadrant 1 or quadrant 4 instead. Now I'm going to pick it from quadrant 1 because the 1 is positive, right? And what is the angle here? It's pi over 4. So the arctan of 1 is pi over 4. And that's my answer. Okay? So you have to be a little bit careful here. If I ask you to find the angle first, yeah, then you're going to get back to where you started. You're going to get back that ratio back again. But if I ask you to find the tangent of an angle, meaning find me the point on the unit circle first, and do the inverse tan or the inverse trig function second, the problem is there's no guarantee you're going to end up in the same quadrant that you started in when you did the first step. So you have to kind of do the problem all the way through. All right? All right, and that's how we work with some combos there. Okay, now let's try inverse trig with triangles. So let's say I asked you for the sine of the inverse cosine of 1/4. Okay, now here's the problem. 1/4, it's not on the unit circle, right? There's no 1/4 on the unit circle. So let's see what we can do with this. Well, let's start with inverse cosine. Inverse cosine lives in quadrants 1 and 2, right? Quadrant 1 and quadrant 2. I'm saying I want the inverse cosine of 1/4. Now that's a positive number, right? So my answer should appear in the angle should be in quadrant 1. But the problem is I don't know what quadrant or what angle it is because 1/4 is not one of the ratios on my unit circle. So what I can do, however, is I could make a triangle for it. I'll put my angle theta here. And cosine is x over r. So I'd have a 1 there and a 4 there. Okay. Now, here's what I'm going to do. I don't know what angle this is. So I just called it theta. So over here, I'm going to do the same thing. I'm going to call it theta. And now I want you to find for me the sine of theta. Okay, I don't know the angle, so I'm just calling it theta, but I want you to find for me the sine of theta. Well, wait a minute. Sine of theta. Here's theta. From theta, opposite over hypotenuse, or y over r, is what I should be looking for. So if I could find y over r, then I can find sine theta, and I don't even need to know what the angle is. Well, I just have to find this y coordinate. But I could with the Pythagorean theorem. So 1 squared plus y squared equals 4 squared. So y squared equals 15. So y equals plus or minus square root 15. Well, I know it's plus because I'm going up. So then sine of theta would be y over r, square root 15 over 4. And that's my answer. The answer to this problem is the square root of 15 over 4. Okay? So what I'm doing here is I'm using this triangle or using a triangle to be able to find the sine of this angle without ever knowing what the angle was. Okay? Because it's not on the unit circle. All right. Let's try the same thing over here. The cotangent of the arc cosecant of negative 5 over 3. Okay. So I want the arc cosecant of negative 5 over 3. Negative 5 over 3 is not on the unit circle for arc cosecant. Okay. Also, we could also do this as arc if you want. You could do it either way. Arc sine is negative 3 over 5. You can do it that way also if that makes you more comfortable. But anyway, Arc, cosecant, and arcsine both live in quadrants 1 and 4. But this is a negative ratio, so I'm going to go to quadrant 4. And I'm going to make a triangle there in quadrant 4. Here's my angle theta. Our cosecant is r over y. The radius has to be positive, so that's 5. And that makes sense because we're going down, so y is negative 3. So now, I don't know what angle this is, so I'm going to call it theta. So what I want you to find for me is the cotangent of theta. Cotan is x over y. So I need to find the x. It's Pythagorean triple. Hopefully you recognize that. 3, 4, 5. So this is negative 3 squared plus x squared equals 5 squared. We end up with x squared equals 16. So x equals plus or minus 4. But we're going to the right, so x is positive 4. So cotangent is x over y, 4 over negative 3, or negative 4/3. And that's my answer. The whole answer to this is negative 4/3. Okay, so we can use triangles to also work our way to working with these combo inverse trig functions. All right, finally, one more. Let's find the secant of the arc cotangent of 4x. All right, now I want the arc cotangent of 4x. It's not even a ratio. It's just a thing with an expression, a variable expression. Well, I could put a 1 underneath. And let's see. Arc cotan lives in quadrants 1 and 2. Now, the 4x is positive. Doesn't say it's negative. So I'm going to build a triangle in quadrant 1. Cotan is x over y. So my x going across is actually 4x, and my y is 1. Okay, 4x is not on the unit circle, so I think the only way to do this is to make a triangle. I don't know what r is. But if I have my angle theta here, then arc cotan of 4x, I can call that theta. And now I want to find the secant of theta. Secant is r over x. So if I can find the radius, I could do it. All right, so let's use the Pythagorean theorem. We're going to use it on this mess here. So we got 4x squared plus 1 squared equals r squared. So 4x squared is 16x squared plus 1 equals r squared. Take the square root on both sides. We need plus or minus. So r is equal to plus or minus square root of 16x squared plus 1. But the radius has to be positive, so it's going to be the square root of 16x squared plus 1. Please note you cannot take the square root of each one of these. Radicals are like parentheses, where you got to do what's inside of them first. You have to add these first before you can take the square root, but you're not allowed to add them. So we just have to leave this as the square root of 16x squared plus 1. We can't do anything with it. All right. So now, if I want the secant of theta, it's r over x. R is the square root of 16x squared plus 1. And x is 4x. And that's my answer. That weird expression there. Okay? So again, we used the triangle to do it. It just that it wasn't two numbers anymore. There was a variable expression of 4x in there. All right? And that's it. That's all there is for this. Okay? Doing combos with inverse trig and using triangles to take care of the problem with the ratio not being on the unit circle. All right? And that's it. And as always, thanks for clicking.